Okay, this is section 6-3. We're going to be talking about scale drawings and models. Before I get started on this lesson, I just want to remind you guys that as you're taking notes, if you have questions that you want to ask us tomorrow or the next class, make sure you write the questions in the side margin so you remember to ask them. And we'll talk about them when we first get together in our next class. Because some of these topics are a little more challenging than what you're used than what we've done in chapter 5 with this method. So we want to make sure we cover your questions. All right, 6-3, scale drawings and models. What we're going to learn is how you use scale drawings and how to construct a scale drawing. And you can think of lots of ways, I'm sure, or maybe at least one or two ways that scale drawings are used in everyday life. And I tried to help you think of a couple. Landscape planners use them to design plans for developments or lawns or that kind of thing. Architectural drawings use scale. You know, every inch on an architectural drawing represents X number of feet of the real building. Because obviously you can't draw the whole building to size because it'd be a mess. It would be way too big. And finally, the other ways we use scale is on a map. Sometimes 1 inch equals 50 miles or 1 inch equals 100 miles, depending on the scale of the map. You've talked about that in social studies, so that's what we're talking about when we're talking about scale. Architectural models use them. Museum models, when they build replicas of things, they use scale, and the old Lionel train sets also are in a certain scale, specific scale, so that 1 inch of the train equals um, so many feet on the real train. All right, a couple vocabulary words. A scale drawing and a scale model are used to represent objects that are too big or too small to draw or build at its actual size. So, and a scale is a ratio. We've had this term already. The ratio, oh gosh, I don't like when it does that to me. Do that again. Scale is the ratio, which we've talked about in the last couple chapters, of the drawing or model compared to the real or actual object. So a scale is that ratio. It's a ratio of the drawing or the model compared to the actual thing in real life. Okay? And that is what scale means. If that's the ratio that it is. All right. So for instance, 1 inch equals 3 feet. So 1 inch equals 3 feet represents an inch represents the actual. So this is the scale is the what would be drawn on the paper, and this is what is happening in real life. So it's 1 inch to 3 feet. Here we have 1 to 24. It could be written like that, meaning 1 unit represents a distance of 24 units. So say 1 inch on the drawing actually represents 24 miles. It could be. Remember, scale is the drawing or the model measurement over the drawing or the model measurement over the actual measurement. And we're going to be working with that ratio in this. Okay, find actual measurements. Example 1. Design. A set of landscape plans shows a flower bed that is 6.5 inches in width. Okay? And the scale of the plan is 1 inch equals 4 feet. What is the width of the actual flower bed? Okay, so we're going to set up a proportion. We're going to look at our two ratios. We have the ratio, remember we said scale was the drawing or model over the actual. All right? So the scale here is 1 inch is actually 4 feet in real life. All right? To solve this, we're going to write a proportion. 1 inch, which is the actual, over 4 feet. Excuse me, 1 inch, which is the scale or the drawing, over 4 feet, which is the actual. And now we have to think, okay, what is the actual width of the plan? That's what we don't know, so that's going to be X. What is the width on the drawing? It's 6.5 inches. Here we have the drawing, right, over the actual. All right. And then we'll solve it by cross multiplying like we learned how to do yesterday. All right, so you're going to 1 times x and 0.5 times 4. So 1 times x is 1x, very good. And 4 times 6.5 is 26. So x equals 26 feet. If I were to write a sentence, looks like a word problem to me, I would say something like, the actual width of the flower bed is 26 feet. If you want to repeat this, it may be worth repeating. And so just go back and listen to it again if you need to. Another example, determine the scale. This time, we're going to figure out what the scale is. Here's the inside of the Lincoln Memorial. Maybe some of you have been there. And it contains 3 chambers. The central chamber, which features a marble statue of Abraham Lincoln, has a height of 60 feet. So the height of the chamber that this statue is in is 60 feet. Suppose a scale model of the chamber has a height of 4 inches. Okay? And the question is, what is the scale of the model? All right. So I think it's always good, you know me, I like my little grocery list. Not only do I like to draw pictures to solve my problems, I like to make my little grocery list. So what is the scale? Well, the scale, we don't know. What is the real height of the chamber? The real height of the chamber is 60 feet. What is the model height of the chamber? It's 4 inches. Okay, to solve this problem, we're going to write the proportion. Okay, so we don't know the scale. We know the model height and we know the real height. So we're going to put the model over the actual. So the model height is, I can't see, 4 inches over the actual height, which is 60 feet. And we're going to set the proportion up for the scale, which we know in the scale model. Um, so to find the scale, we want to know if 1 inch is going to equal how many feet. Well, we don't know. We know we want to have it 1 inch. We don't know how many feet that's going to be. So that is x. So we're going to cross multiply. We're doing a proportion. We're going to cross multiply. 4 times x equals 60 times 1. So divide both sides by 4. You find out that x equals 60 over 4, which is 15 feet. What is that telling us? For every 1 inch on the model, or, then it's actually 15 feet in real life. So it's 1 to 15. That's the scale. Everything we're going to learn today is how to actually construct a scale drawing. Scale drawing, you're actually going to use the actual measurements of the object. The actual measurements of the object is what we're going to use. And then we're given a scale, and we're going to draw it, okay? Antonio is designing a room that is 20 feet long and 12 feet wide. Make a scale drawing of the room, it says. Use a scale of 0.25 to 4 feet. So that means this is the drawing size, and this is the actual size, okay? All right, that's what we're going to use for our scale, half of our proportion. All right, so we have to find to measure the room's length on the drawing, all right? So we want drawing compared to the actual. Okay, so let's let X represent the length. I'm going to go back just a second. So I'm going to repeat myself. Find the measure of the room's length on the drawing. Let X represent the room length. Okay, so we're going to do drawing over, sorry about that, we're going to do drawing over the actual thing. So in our scale, we know that in the drawing it's 0.25 inches equals 4 feet. The drawing over the actual, that's a foot marker, sorry guys, 4 feet. And we're going to compare that to drawing, on the drawing, we don't know how big the length of the room is. So that's going to be X. That's what we're trying to find out. And the actual length of the room, you'll remember, is 20 feet. And then you'll cross multiply and find out that, 4 times X and 0.25 times 20. So you get 4X times 0.25 times 20. And 4X equals 0.25 times 20 is 5. So X equals 5 over 4, or 1.25 inches. So that's what X equals. So on the drawing, it's going to be 1.25 inches. So, okay, so now let's go step 2 and find the room's width. Well, let's let W represent the width. The width is what we don't know. Again, we're going to do the drawing over the actual, right? So sorry for my abbreviations, but let's keep that moving. So we know our scale is 0.25 in the drawing over 4 feet actually. So many inches actually for 4 feet. We don't know what the drawing width is going to be, but we do know the actual width is 12 feet. So again, we cross multiply 4W, 4 times W equals 0.25 times 12. And we find out that 0.25 12 is 3. So we have 4W equals 3. Divide both sides by 4. Right? Cancel out. We get W equals 3/4, or 5. Right? Okay. So then for step 3, you're going to, let me move this guy out of our way and extend our page a little bit. You're going to make your scale drawing, and you're going to use 1/4 inch grid paper. Okay? So you're going to let every 1/4 inch of your grid paper um, be what you need, what a 1/4 of an inch. So we have, for the length, we need 1.25. So we go over 4 of these, 5 of these to be the length, and 3/4, or 3 squares to be the width. And there's our scale drawing. All right. So practice. I have 1, 2, 3, 4 problems for you. On a map of Pennsylvania, the scale is 1 inch equals 20 miles. If you'll do these 4 problems for practice for tomorrow or for your next class period, that would be terrific. Don't forget to jot down specific questions about what you might want help with in our next class. Thanks, guys.